collaboration with NTT Data and Capacity. My name is Nadine Hawkins. I'm the magazine editor at Capacity Media, and I'll be hosting this webinar today. Firstly, I'd like to introduce Brian Foust, Vice President of Customer Solutions, and David Monosov, Director of Network Reliability from NTT Data Global IP Network. Thank you for joining us. Today in this webinar, our speakers will explore the concept of Ethernet services, including an overview of the technologies available today and its features and advantages. Most importantly, they will provide some very helpful do's and don'ts and offer examples of practical applications of carrier Ethernet that service providers and enterprises can implement in their own networks. We will have time for a 15-minute Q&A at the end, so please do send questions through the webinar. In the unlikely event that you experience any technical difficulties, please just refresh your window and this should correct it. And I'll hand over to you, gentlemen.
Hello, and welcome. Very happy that you could join us. We are going to introduce you a little bit to Carrier Ethernet first, and then make sure that we showcase why this product is interesting, what Carrier Ethernet really is, what is it being used for, and kind of which are the optimal use cases where it can be deployed and which are not so optimal. So let's dive right into it and see what Carrier Ethernet really is. So Ethernet, as some of you may be familiar with, is essentially a layer 1, layer 2 protocol, which defines how we interconnect computer networks. It has emerged as a little bit of a winner during the 90s as the de facto protocol that we use for lower layers. And the limitation of Ethernet, of course, is that it is a local frame-based protocol. We have IP and Internet in order to carry us over longer distances as a routed protocol. So one of the emerging requirements for Ethernet was how do we connect local networks over longer distances? And this is the question that Carrier Ethernet really solves. So it is a marketing term, really, but also a standard that defines the set of services that fall under this term and umbrella on how would you utilize Ethernet technology over longer distance networks. The Metro Ethernet Forum is what defined Carrier Ethernet. There exist multiple versions by now. This is no longer a very young effort. Across the different versions, new services and new capabilities were introduced. So there is a set of standardized services. There is a goal of scalability and reliability. There are some principles around service management. There are some functionalities around quality of service, and all of these together are defined as kind of a set of both principles and specific capabilities that providers can deploy. And what this in turn allows a provider to do is to communicate what their service package entails without having to redefine all of it from first principles. So some of the advantages of Carrier Ethernet include ease of use. The idea is that you should be able to just plug into a port of your provider on one side, plug into a port of your provider on the other side, and essentially pretend as if there was a Ethernet cable between the two, port to port, connecting the two switches without seeing any of the complexity. There is, of course, the flexibility. You can service multiple networks over a single port. You have the ability to carry this over pretty complicated underlay networks, and ultimately cost savings. You neither have the added complexity of a routed network, nor do you really find yourself having to deal with leased lines, with any kind of proprietary technologies. Everything just looks like Ethernet end-to-end. Now, the MEF defined a couple different services in order to explain what exactly is happening under the hood in different situations, so that when a provider specifies that they provide a Carrier Ethernet service, they have a way to communicate about it, which exactly defines what's included. The simplest one is E-line. E-line literally is a point-to-point Ethernet service. The ultimate idea is for it to act exactly as an Ethernet cable between two ports. So if the customer has two switched ports on both sides and the carrier provides an E-line service, acts just as if there was a cable connecting one to the other. ELAN is a multi-point to multi-point service. So essentially a sort of a virtual switch. And there are a couple technologies that provide this on the IP overlay network. So for example, VPLS is one such technology, but it really creates a bridged and virtual LAN. E-tree is a tree with a single root concept, with the idea being that there is a single UNI, such as a corporate head office, from which the carrier Ethernet provider terminates multiple different yet separate links to, for example, branch offices. The idea being that as opposed to the ELAN service that we've just previously seen, in the E-tree service, this is not a broadcast domain. Every frame has to pass through the root. So this is really a set of E-lines. And this is the optimal configuration, for example, for topologies where a single corporate head office has, for example, branch offices, which each should have their traffic pass through a firewall at corporate, or any other configuration where it's desirable to keep both separation, yet provide the service through, for example, a single port on the customer side in order to reduce complexity. Now, there are many types of carrier Ethernet, primarily because there are so many technologies that the provider can put to use in order to provide Ethernet over. And one of the real advantages of carrier Ethernet, really, is that it allows the provider to sort of abstract away the technology that they are actually using under the hood, be that dark fiber, be that an MPLS network, be that wavelengths, or an older time division multiplex network such as SONET, be that, dry copper, be that microwave links, anything goes. The ultimate goal is to present this underlay network and eliminate all of the kind of unique characteristics of it and just present it to the customer indeed as Ethernet. So where might you actually want to use carrier Ethernet? What is a good use case for it as opposed to a traditional routed arrangement or other alternatives? A virtual backbone is one. If there is a desire to pass frames in order to be able to speak, for example, the full range of lower layer protocols, BFD comes to mind. Protocols like IGPs, which require their own layer 2. All of this is possible over an carrier Ethernet arrangement, because instead of getting a routed service on top of which one has to once again emulate a private network, this is a layer 2 network, and it's possible to execute all of this directly on it. Backup circuits is another one that allows you to indeed set up direct connectivity, for example, between different office buildings within the same metro area, and another one that's provided by a separate provider, if you, for example, have some physical plant but don't necessarily want to duplicate that physical plant. And of course, carrier Ethernet is a pretty good replacement in many situations for traditional leased lines, for TDM circuits, for older solutions for data center interconnect, for all of these kind of use cases. And finally, for disaster recovery, because again, in a routed network, there are questions about IP addresses and how they would migrate from one device to another. There is added complexity that's required in order to facilitate that at layer 3. On layer 2, as long as the frames go to the right place, if a server fails on one site and there is a carrier Ethernet service to another, then the frames would immediately learn the MAC address that has ended up on the new server, and the frames get right to where they should be. So it's a very easy to implement, very elegant way in some instances to do disaster recovery. It's also common for cloud interconnection, for certain VoIP setups, for certain video setups, especially where there is a broadcast element. There are many use cases in place. Then there is a newer or relatively newer offering that many cloud service providers offer, with the idea being once again to abstract any kind of detail in terms of IP routing, in terms of IP address assignment, to allow customers to perhaps continue using their own numbered resources without creating complex overlay networks. Many cloud service providers allow the provisioning of a carrier Ethernet-alike service straight into their virtual environments. And this includes providers such as Amazon, Microsoft, Google, IBM, Oracle. They all call the solution by slightly different names. But in all of these cases, what essentially happens is that a provider offers this carrier Ethernet service to connect a cloud provider on the one end, typically a specific instance of that cloud provider, so a specific region, to a customer site, and that allows servers that are in the cloud to essentially act as if they were on the local network of the customer. Uh, Office 365 is another application where Microsoft allows utilizing this arrangement together indeed with their express route setup. And this might be something that customers would like to use due to regulatory requirements, for policy reasons, in order to reduce some complexity, in order to maintain perhaps certain cases where special addressing is required, or certain types of firewall appliances are used. So this is one of the common deployment use cases. Uh, SAP is another application, especially for older deployments that are just now being moved into the cloud, where there is a desire from an organization to kind of inflict as little flux as possible to keep everything as is, but move the SAP server deployment into the cloud. That is one of the technologies that facilitate this. And then with AWS Direct Connect, for example, the SAP server footprint can live in the cloud, while the customers are none the wiser. A hybrid cloud, where there is a desire to migrate servers from a local in-house cluster, for example, a VMware deployment, into cloud resources. That is also a good use case because, again, there is no need to deal with the complexity of managing the kind of routed aspects of this, with moving IP addresses, with relearning them. Everything is still layer 2. So the moment a MAC address is just learned on another port, even if that port has suddenly found itself tens or even hundreds of kilometers away through a provider's network, everything continues to work. That's also very akin to the disaster recovery case. If a on-site facility fails, the ability to migrate to the cloud appears, and carrier Ethernet is a great way to facilitate this. And indeed, high availability and resiliency comes up because this is really, again, one of the easiest way to be able to accomplish this. You can deploy multiple sites and interconnect them with a third-party network. You can deploy sites in the cloud as well as one or multiple local in-house deployments. So this is a very close topology, very similar to what we have just seen with the hybrid cloud, but there does not have to be a cloud specifically. Customers find very inventive uses for this, both in-house or both if they have branch offices which have some compute capacity, and they might want to facilitate, for example, shifting workloads between branch offices. Many use cases where this is a very good approach to facilitate the underlying connectivity. Now, while carrier Ethernet alludes to private in multiple instances, there is no implication anywhere of encryption happening, which means the security is primarily an element of separation of different customer workloads by the provider, in terms of not intermingling workloads of one customer and another in terms of not forwarding frames learned from one customer's carrier Ethernet service into ports that belong to a different customer's carrier Ethernet service. And but there is no implied implication that this is secure. So unlike, for example, IPsec, nothing of that sort is implied in the product itself. The frames are typically carried as they are received. However, a lot of layer 2 edge equipment now ships with MACsec capabilities, and MACsec is an encryption capability that can be deployed in router ports and switch ports in order to facilitate adding that layer. And of course, in this topology, if the MACsec device is a customer device, this encryption secret is not in fact shared with the provider, which actually provides for meaningful security. Because if the provider was to encrypt the traffic as it traverses, that does not in fact assure confidentiality to the end customer, because the key belongs to the provider and a host of risks that could materialize would still affect it. Whereas with a technology like MACsec, all of the encryption happens on the far end, on the customer devices. So that provides a very elegant solution. And for the carrier Ethernet provider, this is completely transparent because the provider continues to simply pass Ethernet frames from one port to another through its network without any care or concern for what is the actual payload within that frame. Finally, this also allows for very elegant service multiplexing because this allows a service provider to deliver a single port to a customer over which perhaps in separate VLANs, multiple services are provided. And that could be a set of carrier Ethernet services which connect that port and bridge it to branch offices or destinations of the customer, to various clouds, to any kind of use case. But also next to it, providing, for example, an IP transit service in order to both minimize the amount of ports required and the amount of investment that the customer must make in order to interconnect, reduce perhaps licensing costs that the customer must incur in order to license additional ports, for example, in a firewall setup. So this is a very elegant way to interconnect with through essentially a single cable to a provider, but be able to see multiple services over it and multiplex them together. There are a couple additional considerations for carrier Ethernet. One is, of course, protocol transparency, because while the goal is to act as fully transparent as possible, not all protocols make this possible, and not all carrier equipment makes this possible. Some carrier equipment would try to pick up some frames which pass through essentially this carrier Ethernet service and handle them in some way. For a technical example, for example, LACP frames, if the customer terminates a service across multiple ports, bring up many questions about what would be the correct way to handle them. Is the LACP being handled between the edge port and the equipment of the customer, or should the LACP ports be handled by the equipment of the customer itself on the other side that is supposed to see that essentially the LACP traffic passing through? Is the LACP part of the overlay or the underlay? So there are some edge cases which complicate this a little bit, but the goal of most providers is to provide full transparency. Partial transparency is a lot easier, of course, and the common protocols are typically supported. So IPv4, IPv6, ARP, the ability to add VLAN tags, MPLS. This is kind of the bread and butter of that service. But if we're getting into indeed service protocols like BFD, protocols like LACP, there is often an element of constructive discussion with the carrier Ethernet provider in order to make sure that the right configuration is arrived at, that both parties have the same expectations, that meet the customer needs, and that everything is configured in order to provide the optimal service. MTU is, of course, a question. In Ethernet, there is the standard 1500 bytes MTU, but some customers might prefer jumbo frames to be available. And these are, for example, customers who might use the service in the context of storage, where a 9000 byte MTU or higher might be preferable in order to carry more data, for example, between a storage area network and hosts or situations such as these, or even perhaps carry encapsulated services. And again, this is an element that often is negotiable with the service provider in order to facilitate a good outcome. Uh, Finally, there is, of course, the service level expectations. One of the advantages of carrier Ethernet is that a provider can carry it in many ways, abstract a lot of different failure modes. So many of the failure scenarios in the service provider's network itself can be completely eliminated, made almost completely invisible to the end user of both sides of a E-line or E-tree. But it is useful to have a shared understanding. And of course, the SLA would vary depending on the complexity and distance and the number of single points of failure that might be involved, utilization of third parties to interconnect, and many elements such as these. So it's also, of course, very useful to know the expected usage. And this is both in terms of capacity planning, to make sure that the correct port sizing is used and that capacity is available throughout the service provider's network, but also to discuss what the actual use case is in terms of application to ensure that the service is tailored, if necessary, uh, to facilitate it. There is, of course, also the consideration of on-net versus off-net. For many networks, a lot of points of presence would be on-net, which in turn means that both of the A side port and the Z side port would both be on the network of the service provider directly, which means the customer would be connecting straight to the service provider's equipment. But this is not possible in all cases. For example, in some cases, the customer would want the service terminated at their office, which is not a data center. The office might be in a building to which the service provider does not have reach, and a third party would be used in order to provide a last mile circuit to interconnect the service provider, which provides the long haul section of the carrier Ethernet service, toward the specific building or a specific floor. And of course, in these kind of cases, it's important to understand how this connectivity will be achieved, which technology will be used, which SLAs can be offered by that provider, and that might add some additional constraints. And this essentially covers carrier Ethernet. These are the basics of how the MEF has defined it, what the service is, and how it is sort of structured and used. So with this, I'll hand this conversation over to Brian to walk you through the specifics of how NTT structure this into an NTT service. What exactly is it that we offer and how it looks like? Brian.
All right, thanks, David. So yeah, I'm going to walk you through our global IP network Ethernet services. So first, to talk real briefly about the NTT Global IP Network, we're part of NTT Group. We're a global technology services company. The Global IP Network in particular is a tier 1 carrier network. So we help operate kind of the core of the internet. We are available in 27 countries and in 46 different markets and have over 90 points of presence around the world. So first, let's talk about give you a high-level overview of the Ethernet services that the Global IP Network provides. We have two flavors of Ethernet services today. One that we call vLink, and another one that we call Global Virtual Link, which you may hear me refer to as GVL. It's a common term. Both of these are the point-to-point Ethernet solutions, which can connect two or more locations within the Global IP Network's backbone. So with our vLink and our GVL services, traffic is prioritized over the Global IP Network backbone and provides flexibility, scalability, and redundancy. And I'll talk about that more on the coming slides. Both VLink and GVL have specific SLAs for latency, packet loss and jitter. And the services are comparable with MEF's E-line service. We also have a couple of configurations, which we call VLink Plus and VLink Mesh, which are comparable to MEF's E-tree services, which I'll talk about in the following slides as well. And one thing to make clear is that VLink and GVL are not a VPLS type service. So as David spoke about earlier, this is essentially, think of VLink and GVL as just like a virtualized cross connect or cable connecting two pieces of equipment. So some of the features of our Ethernet services. So one of the nice things is, compared to a traditional private line that you may order from a carrier today, is that we offer bandwidth options similar to what you might have with IP transit. So rather than purchasing a circuit and having all that capacity, which you may or may not use, you can actually right size your purchasing to match your bandwidth needs. And on our services, we have bandwidth options from 100 megabits all the way up to 100 gigabits. And this is great, especially if you have bursty traffic or you need flexibility in that traffic configuration. So let's say that maybe 3 times a month, you have to transmit data for a few hours, and it's going to take a full 10 gigabits of traffic on your service, but the rest of the month that may sit idle. By having a flexible bandwidth solution, you don't have to commit to that full 10 gigabits. You can actually choose a smaller amount because a lot of the time that circuit will be idle. With VLink Plus and VLink Mesh, we can also offer you to, if you wanted to build out a full or partial mesh solution, like a hub and spoke situation, or maybe even like a fully meshed backbone, let's say within Europe or something, we can provide one bandwidth commitment to cover all of those locations. And then as your traffic moves around the network, maybe it's not very, it's very bursty here or there, but this provides you a way to minimize your costs while still having that capacity available when you need it. The global IP network. So now we'll talk really quickly about the global IP network's resilient network design and how we use that. So our basis for building the network is built around resiliency and performance. And so that's kind of where we focus our efforts. And for VLink and GVL, these circuits are tunneled inside our backbone network of our IP backbone network. And so these circuits by default get to leverage that redundancy and resiliency that we have engineered and put in place. This is particularly important when there may be a temporary disruption on the network, an outage or something like that. With a standard carrier or with the standard point-to-point service that you may get from a provider, if the circuit may go down and be out of service. But with VLink and Global Virtual Link, if there is a disruption on one part of our network, these virtual circuits will automatically reroute on the next available path and then be returned to their original path once the outage or whatever the issue was goes away. So that's really nice. And then on top of that, on our network, VLink and Global Virtual Link traffic are given priority over IP traffic on our backbone. So in those similar situations where there may be an outage, maybe some temporary congestion, VLink and GVL packets are forwarded first. So that ensures that those connections stay up and running during those temporary cases. So now let me talk a little bit more about VLink. So VLink in particular is a regional service used inside a region that allows for virtual circuits to be provisioned. We've got different regions on our network, and so therefore we've got some different types of VLink circuits. We've got an intra-Asia options for building VLinks within Asia, intra-Europe, same thing, intra-North America, and then we can even build Ethernet circuits through between the Americas, between North America and Brazil. We offer the same kind of topologies. You can build them as just simple point-to-points. If you want to take multiple point-to-points and create some sort of mesh, full mesh, partial mesh, or whatever, you can do that. One of the nice capabilities of our service is the multiplexing capabilities that David talked about earlier, where we can provision multiple ports, multiple virtual circuits, and even IP transit services on a single physical port by using VLANs to separate them. And so what makes this good, as David alluded to earlier, is just that you can control your port costs, and you can also, more importantly, control your cross-connect costs as well, or your transport costs that go along with that, just to provide. And so then when you combine that with also the bandwidth flexibility of committing to specific bandwidth amounts, it provides a lot of flexibility to kind of tailor make a solution that fits your needs. The VLink services are available at every NTT Data POP and node on the network. If a customer is not in a data center where we're at today, access lines and dark fiber can be used to kind of extend the VLink in that regard to a location. So, for example, let's say that you're in a data center next door to where NTT is in London. You could acquire a dark fiber connection over to us at the data center that we're at, and then we could extend that circuit off to whichever data center on the far end you need to connect to. And then finally, with VLink, the technology service provider interconnection is what we call our capability to connect to cloud providers, such as AWS, Microsoft Azure, and others. And so this just provides additional flexibility. So now you can use that. If you want to go with a multi-port, multiplex solution, you can have all of these services on a single port if needed. This here, VLink options, this just kind of describes the topologies that we've talked about. VLink Direct is kind of what we call our standard point-to-point Ethernet connection. VLink Plus is essentially a hub and spoke arrangement where we can have that one trunk port, maybe at location A, and then B, C, and D can have each physical ports on their opposite sides. And then VLink Mesh allows for the full mesh capability, provisioning virtual circuits between all of the locations. So now we'll switch gears and we'll talk about Global Virtual Link. So for Global Virtual Link, these are our Ethernet services that are intended to be used between regions of the network. So it uses the same underlying VLink technology, but it goes between regions. So same speeds from gigi up to 100 gigi. We can provision between the regions with these. So we can provision between anywhere in Asia to anywhere in North America to anywhere in Europe. The main locations of places in Japan like Tokyo, Osaka, Hong Kong, the big markets in Asia, we can get to, as well as the smaller ones like Kuala Lumpur, Taipei, and so on. And then of course we can connect those either which way over to Europe and to North America as well. All right, so now we've talked a little bit about the products. And now let me just walk through the summary of some of the do's and don'ts that we've talked about here today, and then we'll move on to questions. So first, we'll talk about the do's of carrier Ethernet. So know which protocols you're intending to utilize with carrier Ethernet. As David mentioned, there's this on certain carrier networks, maybe some protocols aren't allowed, and these are going to be more of those layer 2 sort of Ethernet protocols. But in most cases, if you're just running IP traffic across your virtual circuit, those are universally supported. IPv4, IPv6, ARP, MPLS protocols like that are universally supported. But if you get down into layer 2 protocols, that's where you'll want to talk with your provider to see what's supported. We've talked a little bit about multiplexing multiple services on a single port. Keep that in mind. That's a great way to reduce your port costs and also your cross-connect costs. Know what level of service level agreement you need for these services. Every provider has their own SLAs, and so just always review those to make sure those are sufficient for what you need for the purpose of that VLink or carrier Ethernet service. And know your expected utilization. So depending upon how much usage and how much burstability, when you're talking with the carrier Ethernet provider, see what options are available so you can right size the circuit to your needs. Know your building management's position on circuit extensions and contractors, et cetera. And what that means is that when you're going off net, we talked earlier about on-net and off-net. So on-nets are essentially locations where the carrier already has a presence, and off-net may be more of a location where a carrier is going to have to use a third party to reach maybe an office building or something like that. So that part's easy, but there's still another step which can sometimes get overlooked, and it can create headaches for you, and that's just with inside the building itself. So when you are ordering a carrier Ethernet service that's going to go to an office or someplace that's not like a data center or a large office complex or something like that, check with your building management to make sure that to know and understand how that circuit, where it's going to be delivered, and how it's going to be able to get to your office, because oftentimes they have special rules around who you can use for contractors to extend that circuit and other things. And knowing that up front will make your life a lot easier. So also know what type of equipment you will support, interface speed, optics, and protocols. In particular, I would tell you that probably optics are probably a really big thing nowadays. In data centers, you see that most of them have either retired or plan on retiring copper, twisted pair cabling, multi-mode fiber cabling, and everyone is kind of standardizing on single mode fiber. So know what your equipment supports, and make preparations to be able to support that. And your carrier will tell you what options are available, but then also keep in mind the distance limitations of that as well. Copper can only be extended 100 meters. So if your telco room is longer than that away, then you'll need to move to a fiber optic type of solution. Always encrypt your data whenever you're transmitting stuff across any circuit. Circuits of any type are not encrypted by default, like we talked about. So whether you're using MAC-SEC capabilities to encrypt a circuit, or even using, you could use IPsec inside of the virtual circuit if you needed to, or also just even connecting everything through SSL will provide certain amounts of encryption to protect your data as it transmits the network. And then use your cloud provider recommendations. If you are trying to connect to a cloud provider like AWS or Microsoft Azure, make sure that you're taking their recommendations for high availability into consideration, and work to ensure that you'll have a sufficient level of redundancy if that's needed for your particular use case. As far as the don'ts of carrier Ethernet, don't underestimate the installs to off-net locations. Things get better every year. Fiber gets to more and more locations, but occasionally, if you're in an office building that doesn't have a lot of connectivity to it, for example, they may have to trench in new fiber, and that can take months to do. You have city permits, building permits, working with the landlord. So just understand that going in, and that's also a good thing to do just in general when you're looking at leasing a new place for an office building or something like that. Even seeing which carriers are available in that facility, so you maybe can just avoid that altogether. Don't forget the distance limitations that I spoke about just a moment ago. Best advice is just kind of go with single mode fiber, and you're generally pretty good. That's kind of future proof in that regard. And just don't forget that carrier Ethernet doesn't provide security. So MAC-SEC, SSL, you'll need to have some sort of encryption in order to keep your data secure. And that's regardless of carrier. That's just in general. And with that, I think we're ready for questions.
We are indeed. Thank you very much. That was very insightful. First question, how is the carrier Ethernet different from MPLS and VPLS?
Okay. I guess I can take that question, Brian. Thank you, Nadine. It's a good question. VPLS is one of the technologies that allows sort of providing carrier Ethernet style services. But VPLS typically comes with certain complications in terms of what exactly that protocol affords an operator that uses it. And the focus there is on maintaining multi-point single global broadcast domains. There are use cases where this is a desirable complication. There are use cases where this is a complication that only makes the service both more difficult to maintain for the service provider, as well as occasionally more difficult and perhaps even sometimes less reliable to use for the customer. So there are uses for both, but depending on the specific service that is procured from a service provider, a simple E-line, for example, can be provided using technologies that are much simpler and as a result, much more predictable in their behavior, sometimes much more scalable because they don't necessarily need to have awareness of every single MAC on every single port. Depending on the specific configuration, there are basically different approaches to facilitate it, which might result in a more optimal outcome for the customer.
Okay, perfect. If you don't use VPLS to provide the services, what are the options?
So this is also one that I could take. There are multiple approaches to providing this, ranging from, for example, EVPN together with MPLS, EVPN together with segment routing, carrying essentially pseudo wires over an MPLS network. There are countless variations and countless protocols available today that different providers utilize. Entity itself utilizes an MPLS network. So for us, this is a pseudo wire service in different configurations on top of an MPLS network. But different providers would use different approaches and different technologies. There are literally dozens of different mechanisms to essentially provide a comparable service to carrier Ethernet over.
Okay. Can't CE be considered as having innate security compared to the internet due to its controlled environment and dedicated infrastructure? It often includes advanced security features like encryption and intrusion detection systems.
Brian, would you like to take up this one?
Sure. So let's see. Let me read the question again.
Can't CE be considered as having innate security due to its controlled environment and dedicated infrastructure? It often includes advanced security features like encryption and intrusion detection systems.
Yeah. So so CE, I guess that could be customer edge or customer equipment. I mean, anything, so things like, the routers and stuff that are at the customer edge, they may have those capabilities that do, intrusion detection and IPsec and things like that. And what we're just saying is that once you get out, once that leaves your equipment and transmits to the other side, an Ethernet circuit, and this is of any flavor, there is no encryption of that. And so you just want to ensure that your edge equipment is doing that, which you could have devices on both sides providing that encryption. They can also provide intrusion detection, like if you're also using that for, for IP transit as well. And, that's just what we're meaning by that.
And maybe to add a little bit to that, Brian, in many situations, no matter how secure the service provider's network is, whether the service provider offers that carrier Ethernet offering in a completely secure monitored environment, a standard or a regulator might not allow the service provider to have that level of access or to be entrusted to that degree. One use case we have seen on our network for this GVL service especially are payment providers interconnecting their different data centers through our own network. And in order to meet the requirements that are put upon them by PCI DSS, they of course must assure that any data that leaves their data center is fully encrypted and that even the service provider has absolutely no ability to decrypt or inspect whatever is being passed. So this is, for example, one use case where customers typically deploy MACsec on both ends, and then just utilize the service provider as a kind of a dump conduit. Now, that does not offset the fact that indeed, of course, the NTT GIN network is extensively monitored around the clock, has a comprehensive set of security policies, and that carrier Ethernet itself provides a good degree of segmentation and separation between different customers. But the optimal situation is one in which a customer does not have to trust the provider at all. The provider is trusted only to carry the frames, not to ensure their integrity or their secrecy, essentially.
Would a V-Link be a good replacement to Wave services?
Yeah, no, it's definitely depending on your use case, right? So, if you need something and you have high data transmissions going between two sites, a WDM type solution may be the best fit. If your bandwidth commits are lower, where you have more burstability, then that's where a V-Link or GVL type of solution can make a lot of sense, because you're not paying for that capacity you're not using. You can actually right size your connection with your budget, so to speak. So you can get that burstability that you need, but still maybe a lower cost for when you don't need it. And I think you're on mute.
Does the MAC SEC to keep the Ethernet circuit secure, reduce latency, or any other quality transmission?
So I would say that it probably has little to no impact on latency or anything like that. I mean, really, what it's intended to do is just encrypt those frames before they leave the device, and then so it won't affect jitter. It shouldn't affect latency or any other quality. David, would you agree with that?
Absolutely. Modern equipment is typically capable of doing MACsec at wire speed of the port on which the service is provided. So the overhead, if it even exists, is absolutely minimal. It's nanoseconds at this point. There is no kind of additional attributes or characteristics being affected by it. And in fact, as opposed to, for example, a IPsec style VPN, you don't get any resulting fragmentation from deploying MACsec. So the frame is encapsulated cleanly, and the entire frame is still carried as a single frame, as opposed to, for example, a VPN service over an IP transit, where if you have a sufficiently large frame to carry, you would need to first fragment it into more frames in order to fit the IP header and any additional information that might be required. And as a result, you would end up carrying multiple packets per each frame that's carried this way. So you avoid fragmentation by relying on MACsec. You do not introduce any kind of additional jitter. You don't get any additional latency. Modern equipment is very, very capable. There are devices on the market that are capable of doing MACsec at 100 gigabits per second, 400 gigabits per second. So there are solutions at essentially any level of throughput that might be required.
Excellent. Thank you very much, Brian and David, for joining us and providing some great insights and taking those quick fire questions at the end. And thank you to everyone watching. We hope that this has been useful. Please don't forget to subscribe to Capacity Media for more webinars and content like this. Thank you very much.
Thank you kindly for having us, Nadine and Capacity.
Thank you.
Thanks for everyone who has joined.